From the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to NASA's New Horizons Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs, and we're on Pluto's doorstep, getting ready for New Horizons' historic flyby of the Pluto system on July 14th. On July 8th, we're less than a week away, just about 4 million miles from Pluto, and this mission is already making history. Now, we'll come to you each day through the flyby with quick mission updates like this, or news briefings or other programs covering the latest that New Horizons does and sends back from the planetary frontier. And we want you to come along on the adventure. A familiar face from our weekly updates is Alice Bowman, the New Horizons Mission Operations Manager at APL. Alice, welcome back.
Thanks, Mike. Nice to be here.
Let's start with a look inside Mission Operations, and if you can, the Mission Operations Center here at APL, and show us around the room and kind of explain what's happening there.
I'm sure. What you're looking at here in the foreground is the command pit. This is where commands or instructions are sent to the spacecraft. And this is also where we'll get data or telemetry back from the spacecraft. Along the back wall is where the subsystems and where I actually sit, right there near that whiteboard. And then in the back room through those windows is the situation room. And it looks like we have some people over there in there right now.
Another meeting, right?
Another meeting.
The team had an eventful weekend of July 4th. The spacecraft went into what you call a safe hold. Kind of explain what happened.
Sure. Well, we have an autonomy system on board that's programmed to take care of any kind of faults on the spacecraft that it will detect. And this weekend, we had too many operations going on at one time. We were asking the main computer to compress some data. At the same time, we had uplinked from ground instructions that needed to be burned to flash on the main computer. And we actually overloaded the computer. And so the autonomy system switched us to the backup computer in order to keep flying the spacecraft on its normal trajectory.
So that's what it does. It essentially then calls home and says it needs help.
It did. It did. It pointed to Earth and sent us a signal, told us exactly what was going on, and then we went into action.
Now the team's trained for situations like that, correct?
It is. It's one of the basic things that we train spacecraft operators.
So I guess that contributed to what was a quick response. I mean, you had to act quickly for this.
We did. Of course, you know, we're coming up on our primary mission phase, and so everybody was primed for this. And when we got indication that something wasn't right on the spacecraft, everybody went into action. You know, we were all a little bit afraid of what might happen, but we put on our engineering hats and we went down our checklist, and we did what needed to be done to recover that spacecraft to operational mode.
So I'm going to ask the next question by showing a picture, which kind of answers the question, but I'm going to show it anyway. This is the science team celebrating the news that the flyby sequence had kicked into the computers. So I guess that answers the idea that things are back on track?
Yes, things are definitely back onto track.
So let's pick up what happens on the spacecraft over the next few days.
Well, the spacecraft is currently taking science data, and it is also taking optical navigation data, and this is very important because it is a measure of how well we are doing on that trajectory to hit that specific point and at the specific time that the science team wants us to hit. And so that's pretty much what we're focused on now, is to get those science observations at the right time and at the perfect lighting conditions.
And we're close. And now you're really close.
We're amazingly close. It's hard to believe that we're here right now.
All right, thanks, Alice.
Thank you, Mike.
Now, for NASA's New Horizons mission, information will come in all shapes and sizes, whether you like a lot of detail or prefer a summary. And if you're really pressed for time, check out the daily New Horizons podcast called Pluto in a Minute.
How does a planet so small and so far from the sun have an atmosphere? This is Pluto in a Minute. Pluto's orbit actually crosses Neptune's, so for about 2 decades of every 248 Earth-year orbit Pluto makes around the Sun, it's inside the orbit of Neptune. It turns out Neptune has a huge effect on Pluto's orbit, and the two bodies are actually in resonance with one another. For every 2 orbits Pluto makes around the Sun, Neptune makes 3, and scientists think that Neptune is actually the reason Pluto is where it is. One dynamic model of the solar system presented in the 1990s suggested that the planets actually formed closer to the Sun than they are now. It's possible under this model that Pluto formed at about 30 AU. In the mid-2000s, another model was presented called the Nice model that suggested that Pluto could have formed as close as 15 AU. With all these huge gas giants orbiting so closely together, their gravity eventually threw this system into chaos. The planets' orbits were flung further out from the Sun, and all the small bodies were also flung further out. At some point, Pluto and Neptune became locked together in this resonance. So the question is, if Pluto formed closer to the Sun, how close was it? The data from New Horizons will doubtlessly shed some light on this question, but in the meantime, if you want to know more about Pluto, be sure to check out the New Horizons websites, and tweet your questions using the hashtag Pluto-Flyby. And of course, come back tomorrow for more Pluto in a Minute.
For a science update, we welcome back Hal Weaver, the New Horizons project scientist from APL. Hal, thanks for joining us.
Hey, Mike. Glad to be back.
The pictures of Pluto are getting better and better as New Horizons gets closer and closer. But before we get into that, how about remind us what the main science goals of New Horizons are and what the mission is getting at Pluto?
Yeah, the real big picture goals, 3 of them. What do Pluto and Charon really look like? Not these little pixelated blobs seen from 3 billion miles away, but real worlds with complexity and diversity, high definition and in color. In addition to that, we're going to see what Pluto is made of and Charon is made of, their surfaces, 64,000 footprints across each one with measuring the chemical composition over the surface. And then finally, the atmosphere of Pluto, investigating the temperature and the pressures in the atmosphere and how much of it is escaping into space.
And then there are a lot of other things, too, that the mission's going to accomplish.
Yeah, I mean, we got like a little mini solar system here with all the satellites. 6 objects total, and we're going to look at them all.
Okay, let's talk about some of the looks we've had at 2 of the bigger ones, and of course the main one, Pluto. Some of the images that have come back lately, the detail is getting better and better. What are you seeing in some of them?
It's just juicier and juicier. It's amazing. The science team is just drooling over these pictures. If you look at the new pictures now, it's already 5 to 6 times better resolution than what we've been able to get before. We've got these incredibly, we're starting to see structure in those dark regions near the equator. We've got almost something that looks almost like a donut just above that dark region. And can you imagine that we're actually going to get some images of Pluto that are 100 times higher resolution than these images near the time of closest approach for little portions of Pluto. So, just watching the Pluto and Charon getting, better and better resolution is going to be amazing.
Now, they see that some of the pictures that come back, and we're seeing more and more of those, some are in color and some are in black and white. And I think that's for reasons to see some of the different structures. Some allow you to see things that maybe the others don't.
Yeah, that's right. We have the highest resolution camera, the LORI, what we call LORI, the Long Range Reconnaissance Imager. That doesn't have any filters in it, any color filters, because it had to be as sensitive as possible. It takes in all the wavelengths that our eyes are sensitive to. It gives us our highest spatial resolution, but we do have a color camera, MVIC, that's going to has red, green, and blue, that we can take images, put those together with the LORI images, paint them onto the same globe of Pluto and Charon, and actually see what Pluto looks like in living color.
And that's what you guys are getting to see more and more of this as we get closer. And we're seeing more pictures like that coming out online that people can view. And
oh yeah, we're making these images available shortly after they arrive on the ground, and people are welcome to play with them themselves.
everyone's along for the ride as well to do that. The science is back online. So what's next? What's happening over the next few days?
Well, it just gets better and better. You know, just coming in from 6 days to 3 days, you're doubling, you know, the resolution, 4 times as many pixels across the objects. We're going to start to get more compositional information on, you know, Pluto and Charon, trying to, you know, to tease out. We're already seeing some of the things that we've seen in the past, but trying to tease out new information, things that we've never seen before, and that's what this mission is really after. We're going to rewrite the book.
So this is more than just verifying the stuff you saw earlier was there. Now you're getting into the details that, yeah, that's there, and there's some amazing
yes,
stuff
I
in
mean,
it.
you know, we didn't have any idea really what to expect, you know, hardly at all, and this is it. This is our once-in-a-lifetime opportunity to see it.
All right, well, enjoy the ride. Thank you, Hal, for joining us.
Absolutely, thank you.
You know, there are many ways for the public to get involved with the New Horizons mission. Now, one way is to Pluto time. Now, this is a moment during dawn and dusk each day where the illumination on Earth matches that of noon on Pluto. What does that mean for you? Get ready for Pluto time. Join the conversation via Twitter, Facebook, and other social media platforms talking about the July 14th flyby. Send questions at #PlutoFlyby, and mission information along with new images are available online at www.nasa.gov/New Horizons. So that's the latest from NASA's New Horizons mission on Pluto's doorstep. We're less than a week away, about a Pluto day away from the flyby. 4 million miles to go, the countdown to Pluto continues. I'm Mike Buckley, and for the New Horizons team, thanks for watching.